Hello. To start, we are going to ask the question, what is this? What is this monstrosity? How do you even say that? Well, we are asking, what is x to the 1/2 power? Is what we would say. What does that mean? So that's x with a 1/2 up in the exponent. I'm comfortable with x squared, x to the 3rd power, even x to the -2 or x to the 0th power. All of those exponents I can deal with. Now we got x to the 1/2. That is what we call a rational exponent. Rational because, if we recall, rational numbers are any numbers that can be written as a fraction, as a ratio of two other numbers. So whenever we have a rational number up in our exponent, a fraction, it's a rational exponent. So what is x to the 1/2? Well, to answer that, let's do a little investigation. X to the 1/2, well, I can square that just for the purposes of this illustration. X to the 1/2 squared. Okay, well, what is that? Well, think about our properties of exponents. If I take a power to a power, I multiply. So 1/2 times 2, 1/2 times 2, we should all know that. That's 1. So this is actually x to the 1st power, which is equal to just x. Okay, so what did I do there? When I squared x to the 1/2, I got x. Well, if you square something to get a number, what does that mean about x to the 1/2? Why, that means x to the 1/2 is the square root of x. Let's do this with numbers. Let's say I have 4 to the 1/2 power, and I square it. 4 to the 1/2 squared, well, that'd be 4 to the 1st equal to 4. So that means whatever number 4 to the 1/2 is, when I multiply it by itself, I get 4. That's the definition of a square root. Any number that I multiply by itself to get that number. So what's the square root of 4? Well, some number that I multiply by itself to get 4. That's 2. 2 times 2 equals 4. That means the square root of 4 is 2. Because when I try and answer that question, what is the square root of 4? I try and think, what number times itself gives me 4? Well, 2 times itself gives me 4. All of this to say, going back up here to the top, x to the 1/2 squared is equal to x. That means x to the 1/2 times x to the 1/2 is equal to x. So the square root of x is equal to x to the 1/2. This is what our rational exponents mean. And this does help give us meaning because we're a little more familiar with this square root idea. So when I say 1/2, I have that as an exponent. I'm kind of talking about square roots. So the rational exponents give us or allow us to talk about roots of numbers. Okay, so that's kind of what I'd call radical form. So I can write numbers in exponential form in radical form. This would be 5 times the square root of x. Because here it's 5 times x to the 1/2. Only x is being taken to the 1/2 power, so it's 5 times the square root of x. Write 8p to the 1/2 in radical form. Notice these parentheses, they're important. All of 8p is being taken to 1/2. That means I want to talk about the whole square root of 8p. I can go the other way. I can have something in radical form and write it in exponential form. This right here should just say exponential form. Okay, so the square root of 3b. Well, in exponential form, I know that that is 3b to the 1/2 power. The parentheses is important. I'm saying all of 3b, the square root of all that to the 1/2. This is different, okay? Because this is equal to 3 times the square root of b. So that's not what we want here. What if I have 16 to the 1/2 power? What is that? Well, that's equal to the square root of 16. What number times itself is 16? 4. A kind of mathematical definition of these rational exponents. For any real numbers a and b, and any positive integer n, if a to the n equals b, then a is the nth root of b. Because we don't just talk about square roots. That is like the second root. We have cubic roots, quartic roots, quintic roots. Okay, we don't really say that, but we have third roots, fourth roots, fifth roots, sixth roots, really on and up. So the nth root, nth standing for like any number of root, 7th, 8th, 9th root. So symbolically, what I would say is if a to the n is equal to b, then a is equal to the nth root of b. Okay, so suppose 2 to the 4th power is equal to, well, what is that? 2 times 2 is 4, times 2 is 8, times 2 is 16. So it's equal to 16. That means 2 is the 4th root of 16. Okay, so another nth root. What is the 3rd root of 27? So what number times itself 3 times is equal to 27? 3. Try another one. What is the 3rd root of 64? What number times itself 3 times is equal to 64? It's kind of what we're thinking in our heads. 4 times 4 is 16, times 4 is 64. So 4 is our number. Got it. Okay, so nth roots. I don't have to have just square roots. I can go to the nth root. Gives us a lot more power in our computation. We can go to 3rd root, 4th root, 5th root. Okay, take it one more step up. For any positive real number b and any integers m and n greater than 1, b is equal to m divided by n equals... Okay, so I'm going to take that exponential form and I'm going to put it in radical form. B to the m divided by n power is equal to the nth root of b to the m power. Whoa, okay. I can also write this, and this is kind of crazy, I can write it 2 ways. I can also say the nth root of b to the m power. Okay, so b to the m divided by n, that means I take the nth root of b and raise it to the m power. So the number in my denominator goes outside the square root there. The number in the numerator goes to the power. And it depends on context of which way you want to do it. If you want to take the nth root and then take it to the power, or take your number to a power and then take the root of it. Quick note here, this n right here, it's called the index. It's whatever root you're taking to. So that little number outside your radical is called the index. Okay, so in your rational exponent, I do a couple problems here. Simplify 64 to the 2/3. It's easiest to switch this to radical form. So this number in your denominator is the index, or what root you're taking, and then this is going to be the power. So I can either say 64 squared, what's the 3rd root of that, or I can take the cube root of 64 and then square it. Either is a feasible route. And I want to do this one right here. This is a prime example of why it's nice to be flexible and go either route, because 64 squared, well, in my head, what is that? I mean, I don't know. That's pretty high. That's a big number in the thousands. And then I have to take the cube root of it, so I have to think what number times itself 3 times gets me that huge number. It's kind of hard to do. I have to get a calculator for that. But not so for this right here, because here I'm taking the cube root of 64 first. In fact, we did that already. What number times itself 3 times is 64? 4. and then I square it. 4 squared is equal to 16. So this, the 64 to the 2/3 power, is equal to 16. One last problem. 256 to the 1/4 power. Number in the denominator is your index, or your root. And then the 1 up there, that's the power, so 256 to the 1st power. Which, why even write that? Because that's just 256. What is the 4th root of 256? What number times itself? 4 times is 256. Now, you're going to want a small number because when you're dealing with powers, it grows really big. And my bet is, let's take a sneaky little peek over here. 4 to the 3rd power is equal to 64. Multiply this by 4. 16, 1, carry the 1, 256. That means 4 to the 4th power is 256. 4 times itself, 4 times is 256. That means the 4th root of 256 is equal to 4. And there we go, a little introduction on rational exponents.